Good afternoon to the all participants. I, Ravi Gatti, Assistant Professor, Department of Electronics and Communication Engineering, Sri Venkateswara College of Engineering, Bangalore, Karnataka. We welcome you all for the D3 Technical Session 6 for the third phase of the AICT sponsored short-term training program under AQIS program on data science for 5G cellular networks from 3rd to 8 August 2020. In the morning session, we had a resource person, Dr. Suresha sir, Principal, Sri Venkateswara College of Engineering, Bangalore, on a research topic called Data Science for 5G Cellular Networks. On behalf of management and from the head of the Department of Electronics and Communication Engineering, we would like to thank once again for accepting our invitation and gracing this event. For today's afternoon session, we have Mrs. Nidhi Gargande, founder of FactualAI, Bengaluru, on a topic advances in data science, machine learning, and AI. First of all, on behalf of management, principal, and from the head of the Department of Electronics and Communication Engineering, we welcome you for this live event, madam. I would like to introduce the keynote speaker to the participant with a little profile. Ms. Nidhi Gargande is a triple IT Bangalore data science alumnus, currently leading her own startup AI and artificial intelligence learning and development platform. She had worked as a data analyst with an IoT-based product company called D-3, and also she has been into technical education with a total of about 14 plus years of experience. She has worked on various data analytics and machine learning real-time projects. Nidhi has envisioned bridging the gap between academia and industry by founding Factual AI. She always had an entrepreneurial bent and love for teaching. With the help of Factual AI, she is able to pursue both as founder and CEO of Factual AI. Leading through Factual AI strives to provide artificial intelligence and machine learning based solutions to uplift small businesses. In addition, out of her passion, she works to impart the data science, artificial intelligence, and machine learning concepts to the diverse learners. We are greatly honored and privileged to have you with us for this light event, madam. With this introduction, I once again request madam to take over the session.
Good afternoon, everyone. Thanks a lot for inviting me for this session. I'm really glad to be part of this event. And I just hope that you all are finding this session informative and useful. So let's start with the session. Okay, so today I'm going to talk about the opportunities and the research scope you have in data science and machine learning in cellular 5G networks or any domain you name. Okay, so I'll be giving you an overview on data science, machine learning, and artificial intelligence. I'll be talking about the need, the business use cases, the models, and the process flow. Okay, what you usually follow in any typical data science business use case. Okay, and then we'll be looking into the post-COVID opportunities and the research scope what we have in 5G cellular networks. Right. So I'm going to keep my focus today on the latest trending technology, including the data analytics, machine learning, artificial intelligence, big data, and IoT. Okay. So the very first thing to start with would be, how do you understand the data? Okay. So data is basically pursued as, the facts, the figures, the features, the observations, or considered as signal, right? So this is how we pursue data. Okay. And data could be in any form. So if technically you want to categorize the data could be categorized as structured data, semi-structured data, or unstructured data. Okay. When I say data is in its structured format, that means the data which can be, nicely and neatly fit into a tabular structure and thus into the relational database, which could contain, any customer's details, including the demographic information, like name, age, gender, salary related information or the services which the particular customer is taking. Okay, this is example of the structured data. The data could be in unstructured format, like what we see in the image as an image or audio or video signal. So this is the unstructured data, right? Our data could be in semi-structured format when we talk about the JSON file formats or XML file format. This is the example of the semi-structured data. Okay, so we can see now the data could be in any form or the format, right? Now how are we generating this data? Okay, so you can just try to relate this with your real time use cases, like let's say you take up your phone, or you are using your system and you log in. Okay, so with login to your account in any of the application with a click. Okay, or you basically sending a text message to anybody, or image or video, you are generating data, right? So when you tweet or WhatsApp, or maybe you log into Netflix to watch a movie, or maybe you log into Amazon for shopping. Okay, or you are using any health app to track your health records, you are generating data, right? So this is how the data is being generated, okay, by using the digital devices what we have. Okay, and there is a statistic which says that over 2.5 quintillion bytes of data is being created every single day, and it's only going to grow from here. And by 2020, it is estimated that 1.7 megabytes of data will be created every second for every person on earth. So you can imagine the amount of data being generated. And definitely, we need some advanced, sophisticated, complex, efficient, effective, yet cost-effective methods and algorithms in order to store, process, and analyze this abundant data, right? So that is what the data science is all about. Okay, where your data is taking a right through the scientific methods or analytical methods, so that you can derive some meaningful information or insights from this raw data. And this meaningful information or knowledge you're going to use to take smarter or more informed business decisions. Okay, so this is what the data analytics or data science is all about. Okay, and investing in data science technology, okay, or expertise will definitely add a lot of value to any business or professional today. Why? The answer is simple: because the decisions are data driven. Okay, so that is what we are going to discuss in this session, that how this technology is changing the today's business models, and what are the scope and the opportunities you have in terms of the various use cases. Okay, so when we talk about the data analytics, that we understand that data analytics is, or data science is not a new field. Okay, it was already present. Okay, but when we talk about the earlier times, we didn't have much data with us because we didn't have the technology, right? And thus, and moreover, the data what we had earlier was quite in a structured format, right? So a simple BI tool or Microsoft Excel was enough to do the required analysis or data visualization, so that you can take the right business decisions. Okay, and earlier times the statistician used to use some mathematical or statistical model in order to get the insights from the data to take the business decision. Okay, not only the statistician used to work from the evidences what they get from the stats, but there used to be a lot of work, a lot of decision which were based on the gut work, common sense, intuition. Okay, and so on. Okay, so this is, I'm talking about the past data analytics. Now moving to the present data analytics. Okay, where the data, we are talking about the decisions, business decisions, which are data driven, and we are using the same old scientific methods, okay, in most of the use cases, but added with lots of data and the latest technology, and definitely along with the business knowledge, right? So data science is basically used to solve real world business problems, right? So this is how the data science has evolved with the growth of data, with the radical improvement in the technology, okay, and with the introduction of the present AI, the machine learning, and the deep learning. The data science has come into so much limelight, okay, and that is the reason why it has become so popular, okay, and thus with this evolution of in the technology and the growth of data, there is also change in the role, okay, which is defined to do this particular task. Okay, so now the this complete task of doing the statistical modeling, data mining, data analysis, feature engineering, and predictive analytics, this all responsibility or the role basically falls under data scientist. Okay, so now data science in technical term, if I want to define, data science is a multidisciplinary field, okay, where it uses the scientific methods, processes, algorithms, and systems to extract the meaningful information or insights from the raw data, okay, and those insights are basically used to take the smarter or rational business decisions. So we can see here from this diagram that data science basically sits between at the intersection region of computer science, maths and statistics, and the business or the domain expertise. Okay, so you are required to have the knowledge of maths and statistics in order to do the required statistical or predictive analytics. Okay, you should have a good knowledge of the programming languages. Okay, and generally we go with the Python or R to do to do the scripting or the analysis, and you need to have the required domain or the business expertise so that you understand that what drives your business profit. Okay, and you should be understanding the attributes, what you are taking, what you have in hand to solve the given problem, right? So why we call that the data science is using the scientific methods, because here just like the natural sciences, it is going using the systematic way of collecting, observing, experimenting, measuring, and formulating, testing, and modifying the hypothesis. Okay, so it is working exactly the same way how the natural sciences work, and thus we call that the data is basically taking the right through this scientific methods, and that is what we called as a data science. Okay, so I just hope that you got an intuition about that, what exactly the data science is, okay, and how it is used now. Okay, so what kind of insights you get from the data. Okay, and there could be multiple examples, okay, but here I have just taken one very interesting example. When we apply data analytics onto an any data, raw data given, uh, we basically try to extract the insights. Okay, and some insights could be quite obvious from your domain knowledge or business knowledge or your understanding on data. Okay, like let's say if you are visiting a mega store, okay, for shopping, so you see that, okay, how the particular segments, the stuff in the different segments is arranged. Okay, and there is a statistic or there is a analytics behind it. Okay, that at the billing counter you see certain items like chocolates or the handy items which you can pick and eat. Okay, or maybe when you enter, maybe on the very first side, you will left hand side, you will see maybe the woman wear. Okay, or maybe on the right hand side you will see all the beverages or fruits or vegetables and so on. So you see the how the basically the shop, the segments in the shop is arranged. Okay, and so that you can pick the relevant item the moment you enter. Okay, and basically that is to enhance the user shopping experience. Okay, so few pattern you will find, okay, these are quite obvious. Okay, like all the baby items are kept at one place, maybe all grocery items are kept at another place, and so on. Okay, but there are some unobvious patterns that can also pop out from the data analytics. Like here one example I have taken from an analysis done in US mega store. It was found that the diapers and the beers are usually sold together. Okay, you cannot actually think about this kind of pattern which might be hidden inside the data. And by data analytics you can talk about and find out this kind of insights also from the data. Okay, accordingly you can do your rack management. And once this study was done, after that the beer and the diapers were kept together so that they can not only improve the user shopping experience but also the sales and the ultimate revenue for the particular business, right? These are some examples what we have, that we talk about getting the insights from the data through data analytics. Okay, and ultimately you're getting this insights to take the right business decisions. Okay, so now when we are talking about this big data to be generated, okay, and IoT is one of the most prominent source of generating this big data. Okay, so when we talk about the evolution of internet, we know that the past internet was very expensive, slow, and not generating too much of data. Okay, but when we talk about the present internet, it is basically referred as IoT, because it is not only just connecting the people, but it is also connecting the things. Okay, and thus we can see all the digital devices around us are connected, okay, by some means. Okay, and the future of the internet is going to be the internet of everything. Okay, where you could see everything all around us would be connected, okay, and will be communicating with each other. So you can imagine the amount of data will be generated through all these connected devices. Okay, so this is the big source of generating the big data or the huge amount of data, right? So now coming to the next technology, what we have is artificial intelligence. Okay, and artificial intelligence was already present from I think in the late 1940s. Okay, and that time it was widely accepted by the people. But after a few years, we all saw the AI winter, where we could see the limitations or the constraint the artificial intelligence had. Okay, we understood that that AI wasn't that intelligent. It was explicitly programmed to make certain rational decisions. Okay, and it used to work in quite constrained environment. Okay, so we saw that AI winter. And then from early 2000, we again saw the boom with respect to the AI technology, with the introduction to present AI, which is machine learning, right? So machine learning is just a technology which falls under the big umbrella of AI. Though AI includes multiple, AI basically includes multiple technologies. Okay, and machine learning is one of that. Okay, so machine learning falls under artificial intelligence umbrella. Okay, and here I'm just talking with respect to machine learning. So let's talk about the present AI as machine learning. And machine learning is all about being self-aware. Okay, so you are just giving the capability to the machine to learn from the data automatically, without any human intervention or without being explicitly programmed. Okay, so how we human learn? Okay, we learn from our past experiences, observations, the knowledge what we acquire over the time, and from our past mistakes. Okay, so this is how we learn. Okay, and we know that okay, the machines are having the capability in terms of the very high computational power as well as the memory capacity. So you are now just trying to give the intuition or the common sense, or what do you call, some kind of empathy to machines now, and making machines to learn. Okay, how human learn. Okay, so this is what the all idea about the artificial intelligence or machine learning is, that you are giving machines the capability to learn from sufficient number of examples or training data. Okay, and so that machine learns, try to identify the patterns, the structure, or the trend which is there in the data, and not only just the learning but also improving uh, from the data, right? So this is what the machine learning is. Okay. And I'll talk about it maybe in the further slides, okay, maybe in more detail. Okay. The next question would be that why data science and machine learning has become so popular. Okay. So we have seen that, okay, we have the abundant data with us. Okay. Almost all the B2C services, what we see that there is huge amount of data being generated by the users. Okay. And we have this democratized models and learning algorithms with us. Okay. Where the researchers have already done a lot of experimentation and created the APIs available for us, which we can directly use, okay, based on our data, the understanding on data, the size, the dimensionality, okay, and the problem in hand. We can decide, and choose the right KPI or the model. Okay. And we can do the required analysis or the whatever problem we are trying to solve. Okay. Maybe related to the prediction or classification or maybe clustering, right? So now we know that, okay, we have this abundant data. Okay. And that is going to be the input to this model or the learning algorithm. Okay. And you can imagine that how computationally intensive or the expensive this process is going to be. Okay. So for that we have the relatively fast and the cheap cloud or the distributed computing devices or the environment with us, which makes this possible, right? So this as a combination, the data, the devices and the democratized model make this technology very popular, okay, and successful. So like let me just talk that I am being in a startup. If I want to work, okay, I do not need any infrastructure. Okay, I can just do everything by taking the cloud services. Okay, like from the data acquisition till the model deployment, monitoring and maintenance, everything I can do on the cloud. Okay, so I have those facilities available, and how much ever I am using, I need to only pay for that. Okay, so we have this facilities available to make any application possible, right? So that is the reason why this technology has become so popular. Okay. Now the next question arises is that why do we need machine learning? Okay, so for that we need to understand that how we have graduated from the typical expert or the rule-based systems, right? So we understand, okay, that what are the expert systems or the rule-based system which are still used by multiple applications. Okay, but why we are talking about the machine learning? Okay, so this is just one simple example I have taken here. Let's say a company is hiring for the candidates. Okay, and the hiring manager basically looks into certain attributes or features, okay, as input, and decides whether the given candidate will be hired or no. Okay, so he looks into maybe the 10th marks, 12th marks, whether the person is graduated, okay, what is the CGPA and what kind of projects he has done. Okay, so let me see, these are the input features I have on which basically I look into and decide. Okay, so here the expert based system would be basically a hiring manager who is framing certain rules and this just writing a nested if and else logic. Okay, and based on that it is taking a call that the given person would be hired or no. Okay, now this will work fine in this situation uh, when we have the limited data with the limited number of features. Okay, but you can imagine the scenario if you have lots of data with lots of features, then it becomes almost impossible for any human to hand code this rules. Okay, where sometimes it may happen that the expertise the expert person will not even knowing that what is the association you have between the different attributes. Okay, how do you relate the 10th marks with the projects? Okay, or maybe the graduation with the awards what you have received. Okay, so it becomes really difficult to frame such complex rules, okay, and then to take a call whether the person will be hired or no. Okay, so when we have lots of data, we have lot many rules, we have so many features, and sometimes it may happen that the rules are unknown or inexpressible. Okay, so we need to move towards the machine learning, where we are not completely keeping the expert out of the loop. Okay, we need the expert to understand the attributes as per the domain knowledge, as per the problem in hand, and that to do the feature engineering and the model selection, right? So we are outsourcing some of the functionality which cannot be handled by human or expertise, and we are just outsourcing that to machine. Okay, and we say that, okay, we are telling machine to figure out that what kind of association the input and output is having. Okay, so that is what is done through machine learning. Okay, when we have lots of features, so let's say I am in the same example, now I am adding not only these five features, but I am also talking about whether the person has done any research, okay, or whether he has done his PhD, or what kind of publications he is having. Okay, whether he has patents, whether he has awards. Okay, so my list goes on, my attribute list goes on, and now I have to decide based on these many attributes or features whether the person will be hired for the job or no. Okay, and then it becomes really tedious for any human to come up with such complex rules and define the weightage for the different attributes. Okay, so we need machine learning in this case, and we guide the machine. We feed the machine with the data. Okay, and we guide the machine that, okay, we saying that, okay, there exists some kind of relationship between your input and output. Okay, and you figure out that which function out of the family of function would best describe the data. Okay, which best describe the relationship between input and output. Okay, and not just that, but also the machine learning algorithm would try to figure out the optimized value of the coefficients of or the parameters what you have to describe the model equation. Okay, so this is what machine learning is. Okay, where you're feeding the machines with the label data. Okay, if it is a supervised machine learning, and you are telling the machine, see, this is how the y and the x are associated. Okay, and you learn from it and give me the model by finding the optimized values of the parameters. Okay, and so that I can just use that equation as my model, and for any new instance or new test data point, I have to just plug in that value to this equation, model equation, and I'll be able to get my y for that particular instance. Okay, so this is what the machine learning is. Okay, and we definitely need machine learning whenever we are having the lot of data with us. Okay, so scenario when you need machine learning. Okay, generally we need machine learning for the descriptive analysis, for predictive analysis, and for prescriptive analysis. Okay, so whenever you want to find out the business KPIs, the key performance indicator, which is going to have a influence or impact on your business. Okay, so if you want to find out that KPIs, significant features, you go with the descriptive analysis. When you talk about making certain predictions or forecasting, okay, then we use machine learning. Like let's say you want to predict that for a particular product category, how much sales are going to happen in next 6 months. Okay, so you are just trying to make some prediction on the data, and you are trying to find out, okay, accordingly you will have your inventory management or maybe the transportation or other stuff, right? So this is the predictive analytics. Prescriptive analytics is basically related to the recommendation that you are recommending the right and the relevant products to your users. Okay, so that their shopping experience could be increased, and the user behavior could be changed, okay, and they end up buying the recommended products, okay. So these are the main three use cases or applications you have for machine learning, and there are multiple scenarios in which you would need machine learning, okay. Like, let's say if you want to take, the immediate action, okay, you have a lot of data and lot many features, and you have some latency requirement, or you want to save your resources, okay, you can use machine learning, okay. Like the use case you have for the credit card fraudulent detection, okay, and you want to, the moment some kind of notorious activity or unwanted activity is happening, you need to immediately, identify that activity, and take the right measure or the action, right. So you need machine learning in such scenario, okay. You need machine learning whenever you want to, automate some mundane or time consuming manual processes or routine processes, okay. One example could be the use of chatbots, okay. So for customer care services 24 by 7, you basically replace the humans with the chatbots, and for any given queries by the customers, the NLP based chatbot would be able to handle and answer those queries, right. So chatbot is the example of natural language processing application, right. Similarly, let's say you're working with, a company in HR department, and let's say, you are just trying to categorize the complaints which is given by the employees, okay, or it could be applicable to any B2C services, okay, wherever you're dealing with the customers, and you are just trying to categorize the complaints which is given by the different customers, okay. So let's say I'm taking the employee example, the HR example, where the employee is writing a mail to HR and mentioning, a long message saying that, he has problem with the salary hike, okay, and another mail he receives from another employee, and he is just writing a mail and saying that he has problem that, he hasn't given with the on-site opportunity, okay, past 2-3 years. So this is what the issues they have, okay. And every time for the new mail which is coming from the employee, the HR manager or whoever is the responsible person, he has to go through the mail, and manually he has to figure it out that, okay, this issue is corresponding to what, okay. So you can automate this process, and you can make the machines to automatically categorize or classify these complaints for you, okay. So this kind of work you can automate using machine learning models, right. So there are multiple applications where, the human may not be very accurate, efficient, and fast, okay, where the machines can be, like the language translations, okay, or maybe the document classifications, okay, face detection, object detection, video analytics, okay. So there are multiple such use cases where the machine learning outperform, okay. So here I have just listed few more things, like whenever you want to understand the unstructured data, it is good with ML, okay. Whenever you want to personalize the applications, it is possible with ML, okay. You can improve the user experiences with ML, okay. You can predict the business metrics, automate the business processes, what we just discussed, okay. So these are the scenarios, few scenarios in which the machine learning is used, okay. And I have just taken here a few examples. So wherever you have multiple features with you, you can use machine learning, okay. If you have less number of features, then you're good to go with the data analytics also, okay. But machine learning will help you not only just analyzing and getting the insights from the data, but you can also use machine learning for classification and prediction, okay, and for the segmentation also. So here I have taken few more examples, okay, related to let's say here I have just taken a bike sharing, the rental bike company, which looks into various features, that how he has to stock the bikes for the rental for the different stations, okay. So there could be multiple parameters which would drive the stocking, Okay. And we have to look into the various features, such as that do you have any university nearby, or do you have any the IT park nearby. Okay. Or whether you are talking about which particular day of the week. Okay. And which season. Okay. So there are multiple driving factors which will decide this stocking of the bikes for rental. Okay. For the different stations. Okay. Similarly here, like talking about the Air Asia, that how it stocks the meals in the different flights. So there could be multiple features which will be describing this. Okay. Maybe the size of the plane, from which origin the flight is beginning, what is the destination, what is the departure time of the day, arrival time of day. Okay. Is the flight direct? So there are multiple features which will be describing, and based on that the task would be, or the decision would be taken, right? Similarly, you have few examples where you talk about the ML applications for personalization. Okay. Like Google Map, you see the Google Map basically takes your location data, and you can use the Google Map to reach from one particular point to another point. Okay. But it not just that, but it also helps you to helps you with the right recommendations, saying that that you can visit, if you are traveling to a particular destination, it can recommend you with the right choices for the visit. You can visit a particular place nearby, or maybe you can eat in this restaurant or something like that, right? So these are the scenario in which the machine learning could be applied. And in short, machine learning basically used to make better decisions, to make smarter products. Okay. To automate the manual processes. Okay. When I talk about the smarter products, the example could be the recommendation systems. Okay. Or maybe the PA systems like Alexa or Siri. Okay. Or you have the self drive autonomous car. Okay. So these are the few examples. Okay. Where the machine learning is playing a very important role. Okay. uh, with the recommendation system, you would see that that Google tells you that what web pages to visit. Okay. Facebook can suggest you what pages to like. Okay. Netflix tells you what to watch. Okay. And Amazon tells you what to buy. Okay. And there is the mathematics behind all this systems. Okay. Where the machine learning is applied. Okay. So you have multiple applications, like understanding and predicting the footfall in the particular store. And through video analytics, you can also analyze the customer's purchasing behavior, and can improve, their personalized shopping experience. Okay. So this is where the machine learning is used, for enhancing the personalized user experiences. Okay. Now, coming to the different types of machine learning you have. Okay, so you broadly categorize the machine learning algorithms into supervised machine learning algorithms, unsupervised machine learning algorithms, semi-supervised machine learning algorithm, and deep learning or reinforcement learning. Okay, so this is how you categorize the machine learning algorithms. And supervised machine learning algorithms, as the name suggests, you are feeding the machines with the label data. Okay. So you are telling that, okay, this is the input X, which is the feature set. Okay. And this is the output Y. Okay. And you're feeding the machines with both X and Y. Okay. And Y is basically the label data, or your outcome variable. And you're telling the machine that this is how the input and output is associated. Okay. And now for any new instance of X, the machine should be able to figure out what the Y would be. Okay. So this is what the supervised machine learning is, that you are feeding the machine with the label data. Okay. And the machine is learning from the label data, understanding the relationship between X and Y, and trying to figure out, and coming up with the most optimal function. Okay. And using that for the prediction or classification. Right. So this is what the supervised machine learning is. However, the unsupervised machine learning algorithms are where you do not feed the machine with any kind of label data. You do not have the y variable there in the data set. You just have your feature set with you, and you are just asking machines to figure out the inherent pattern or the structure or the trend what you have in the data, and machine will identify that structure or trend in the data, and then accordingly it will segment the similar data points into one group and dissimilar or different data points into different groups. Okay, so you are segmenting the data points which are exhibiting the similar traits. However, the different groups are having the different interest or the properties, right? So that is the unsupervised machine learning algorithm. Okay, then you have reinforcement learning. Reinforcement learning basically based on the agent and the environment concept, where it just follows the principle how we human being learn. Okay, we learn from our observations, our knowledge, our experiences, and over the time we will update and enhance our what do you call the values over the time, okay, or the beliefs over the time. Exactly the same way the machines are learning. Okay, they just go in the sequential manner and just try to take the right decision every time, and for the long term it just tries to retain that right decision so that it can be rewarded. Okay, so the moment machine takes any right decision, it is rewarded, and the moment it takes any wrong decision, then it is punished. Okay, so this is the concept the reinforcement learning uses. Okay, and machine basically tries to learn from the mistake so that it maintains the long term reward. Okay, so this is what the reinforcement learning is, okay, which is the future of machine learning. And deep learning is basically the concept which is inspired from the very tiny part of human brain, which is neuron, and that is basically just mimicked as perceptron. And then we talked about the artificial neural networks, the convolutional neural networks, and the recurrent neural networks. Okay, so deep learning is the part of this. Okay, and machine learning basically you classify into these three or four categories which we just discussed. Okay, and you will see that your 90% of machine learning success is coming from the supervised machine learning algorithms, okay, which revolves around regression and classification. Okay, so now you understand that, okay, artificial intelligence is a big umbrella under which machine learning falls. Okay, and deep learning is falling under machine learning. Okay, so deep learning is a subfield of machine learning. Okay, and reinforcement learning is the part of deep learning. Okay, so your most of the use cases will revolve around the supervised machine learning algorithm. However, you have the application related to unsupervised machine learning algorithms like segmentation, clustering, association problems, dimensionality reduction. Okay, so these are all the problems what you have as unsupervised machine learning algorithms. Okay, however, regression and classification, these two algorithms fall under supervised machine learning algorithms. Okay, so this is how the classification regression problems are defined, and similarly clustering and anomaly detection problems are defined. Okay, so when we talk about the regression problem, regression and classification, as I told you, these are the part of supervised machine learning algorithm, and you are feeding the machines with the label data. Okay, and here when you say that your y, which is your outcome variable or target variable, when it is taking the continuous values, okay, or it is continuous in nature, it is a regression problem. Like let's say, just try to relate this with the real estate problem, where given the location, the size of the house, okay, the number of bedrooms or bathrooms or balconies it has, the area in square feet, okay, or whether it is near to any IT park, it is near to any school, okay, and certain features are given to you, and you are trying to predict the the price of the house. Okay, so here predicting the price of the house is basically the price is the target feature or column which is taking the continuous value, and thus this is a regression problem. Okay, so looking at certain features and identifying the importance of those features, you are able to decide on the price of the house. Okay, so this is a regression problem. Okay, classification problem, when you are talking about again the label data, but your y variable is now taking the discrete value. Okay, so it is categorical in nature, and it can take one value out of the finite set of values. Okay, let's say you are designing a classifier, email classifier on server. Okay, and you say that okay, any mail which is having certain mail body or the title or the subject, I will identify this as or classify this as spam, and then it should go to the spam folder. Or another mail which I receive and I look into the mail body, the text message, certain words or the combination of words in the subject and in the mail body, and then I identify or categorize that as a ham. Okay, and that should be put in the inbox. Okay, so this is a classification problem. By looking at the mail, first of all, I'm feeding the machine with the label data, saying that this is how the spam looks, this is how the ham looks. Okay, and giving the sufficient examples or sample data to machine, so that machine identifies the relationship between x and y. And then now for any given new email, the machine would be able to categorize or classify it correctly as a spam or ham. Okay, so this is a classification problem. Okay, however, when we talk about the clustering or the segmentation problem, it is a unsupervised machine learning algorithm where, as I told you, you use some similarity matrix, and based on that you will be identifying the similar users. Okay, and all the similar users you'll put in one segment or one cluster, and such different segments you'll be having of different users or customers, right? So the best example could be the customer segmentation done, so that you can design the different marketing strategies or maybe the campaign for the different segments of people. Okay, based on your use case. Okay, so this could be one example of the clustering, the customer segmentation or market segmentation or maybe the product segmentation. So this is the clustering problem, and it is an unsupervised machine learning problem. Okay, similarly you have another kind of application as anomaly detection, where you're just trying to figure out the rare events. Okay, the data points or the observations which are diverging from the distribution what the rest of the data points are having. Okay, and you are able to you are basically trying to identify those anomalies. Okay, so anomalies could be both positive and negative. Okay, in terms of fault detection or identifying any fraudulent transaction, could be an example of the negative or the rare event. Okay, however, let's say if you check that one of your product sales have suddenly risen up. Okay, or maybe the demand of a particular product has increased suddenly. Okay, so this is a positive event which is also considered as an anomaly, but that positive anomalies are welcomed by the market. Okay, however, for the rare events or negative anomalies, you try to basically take the right measure or the action immediately so that it can be handled. Okay, so you would see that that data science, machine learning or AI applications are almost everywhere. It is just automating the world around. Okay, and it is providing you the cost effective solutions because the decisions are driven by data, and it is possible by technology, right? So any domain you name, healthcare, e-commerce, banking, finance, education, crime, agriculture, telecom, core engineering domain, gaming, sports, everywhere you would see the wide use cases of artificial intelligence and machine learning. Okay, so here I have just mentioned few of the use cases or applications. Okay, and you will have a lot of research scope in the healthcare domain. biomedical imaging, okay, for diagnosis of the particular diseases, for preventive healthcare. You will have a lot of scope. You have a lot of research scope in education field also, where you can work on the projects related to the behavioral analysis of the students, okay, to check their performance on academics, okay. And maybe you can come up with the right set of books or the right strategy to make them understand certain concepts, okay, or maybe recommend them some mental games, okay, so that they can improve. So you have a lot of scope in almost every domain, okay, you name. Maybe the finance, computer vision, gaming, NLP applications related to language translation, maybe image captioning, okay, object detection, face detection, video analytics. So you have variety of use cases everywhere. Okay, so here I have just mentioned few of the applications of deep learning. Language translation. You can also use machine learning to protect the rainforest, the illegal deforesting happening, anywhere. That can also be tracked using machine learning. Okay. And here some statistic which shows that greater than 85% of the customer interaction will be managed without a human, and 87% of US B2C marketers believe chatbots and virtual assistants will play a significant marketing role by 2021. Okay, so you can see the wide use cases of AI ML. Okay, and AI ML just not does this required analysis, but it also used to generate the data. Okay, so you can also use this technology to create the data for you. Okay, so you would have heard about the GANs, where you can generate the new images, okay, from the existing set of images, okay. And you have this TensorFlow Magenta project, where the ML is used to create the music. So from the what do you call, the corpus of various music, it is trying to create its own new music, okay. So we have seen, okay, what are the algorithms we have, what is the typical use cases or the application we have for data science, machine learning, and AI, okay. But when you start your problem, the very first question would come is, how do you curate the data, okay, where do you get the data from, okay. So it'll be totally depending on what problem you have in hand, whether you're trying to work on the public data or you're working on the private data specific to your industry, banking, telecom, education, finance, marketing, okay. So these are all private data. Public data, which is available publicly, which is released by government, okay. So you have access to those public data, and you can explore this data.gov site to where you are given with all the agriculture, education, finance, your census data, all this data that you will get there year wise, okay. And you can use this data directly, and you can use it for your analysis, right. There are certain the third parties, which companies which can take your data, and which can give you the label data, okay. So if you have images, and but you do not want to waste your time in labeling that data, so maybe you can pay to the third parties, and they'll create the label data for you, okay. So that is another option you have. Or else the last option, where you see that, okay, you have to create your own data, label data, right. So these are the three ways in which you can cure the data. You can basically curate the data, okay. Now once you have the problem in hand, and once you have the relevant or the required data with you, you talk about applying the data science or the machine learning onto your data, okay. And now here specifically I'm talking about applying the supervised machine learning algorithms onto your data, okay. So whenever you apply any kind of machine learning algorithm to your data, just try to relate that with these 6 building blocks. Okay, and you will have the complete understanding on it. Okay, so the very first block is the data. Okay, that what basically what kind of data you have, or when you have data, what can you do with that data? Okay, so you have data, you define the task. Okay, that what exactly you're trying to do with this data, what kind of analysis you are trying to do on this data. Okay, so task you define, that is your objective. And then you talk about, okay, there is some machine learning model which I can use to do the required task. Okay, and that machine learning model is nothing but the output of the learning algorithms. Okay, so what kind of learning algorithms I'm using? Okay, and that learning algorithm will be actually giving you the model as the output by minimizing certain cost function or loss function. Okay, so I define the learning algorithm which defines the cost function or the loss function. Okay, and the learning algorithm will try to minimize this loss function and try to produce a model as the outcome, which I'll be using for my task to be performed, right? And so this is how I define this 5 blocks. And once my model is built using this learning algorithm based on what data and the task I have in hand, the next thing would be, how do I evaluate my model? Okay, so the model building is just not enough. You need to evaluate or test your or validate your model, that how it is going to perform on the test data or on any unseen data in the real scenario, right? So you need to evaluate your model. Okay, and for that you will be having the different evaluation metrics, okay, which you need to calculate, and you'll be seeing that, okay, if you're getting the desired values of those evaluation metrics, then you say that you're good to go, and maybe you can deploy your model, right? So these are the 6 main building blocks of supervised machine learning you have, which you need to look into and try to relate with. Okay, so you have data, but how do you feed the data to the machine? Okay, so you have data, but you have to make sure that the machines can understand only numbers. Okay, so in whichever format the data is, as I told you, it could be structured data, unstructured data. Ultimately, you need to transform that data to the numbers so that it can be used by the machines or understand by machines, right? So let's say here I have taken the image data. It is a scan data, okay, images. And let's say these images are having the size as 28 cross 28. Okay, and it is a black and white image. Okay, so it is having just one channel. Okay, so here you would see that X is nothing but the pixel values you have, which is 28 cross 28 matrix. Okay, so all these images are having this pixel values of size 28 cross 28. Okay, and you have just one channel because it is black and white image, and this Y is your label data, which is looking at the scan. You are feeding this data to machine and saying that, okay, if this is the image, then the person is not having the disease. If this is the image, then the person is having the disease. Okay, so this is what the label data you're feeding the machine with. Okay, this is with respect to the image data. Now if you have the text data with you, then you have the certain mechanism or the methods to convert this text message to numbers. Okay, so we have this interdocument frequency or term frequency components. Okay, or maybe we can use the vectorized code to convert this text documents to numbers, which can be consumed by the machines. Okay, so again, this data is also label data. Okay, and with this you are just trying to check, okay, that let's say this is the review given by the customers for a particular product, and you are just trying to identify that this review is a positive review or negative review. Okay, so here you can see the Y, which is your target column, can take 2 possible values as positive review or negative review. Okay, so your data should be encoded as numbers. Okay, and the data could be any dimension. Okay, next thing is the task. that you have the data with you, but what kind of task you can do using machine learning. Okay, so let's say here I have just taken a example of Amazon one product page. Okay, and here you can see that on this page you will see all the specification, the technical specification of this mobile phone which I am looking for. Okay, here looks quite in semi-structured format. Okay, here you see some images of the phones. Okay, here you see the tabular structure of the specification of the product. Okay, here you have the reviews with the ratings. Here you will see some frequently asked questions along with the answers. Okay, so this is how this product page looks. Okay, and now I have this data with me, but what in all I can do with this data. Okay, so I can define the various tasks so that I can increase the user's dwell time. Okay, and I basically want my user to, whenever he logs in, I want him to stay on this page. Okay, and not only just putting the particular product in cart, but I also want him to buy the product. Okay, so this is what my objective is, business objective is. Okay, and for that we can define the different tasks here, which can be solved using machine learning. Okay, so the first task could be that, okay, this can I convert this data to look like in a more tabular or the structured format, so that it becomes easier for the user to read this. Okay, that what are the specification of the products we have. Okay, another thing could be that from the review section, can from the review section and from the specification section, can we just derive some frequently asked questions and answers, so that the new user, when he logs in, he can just look into all this, and he might have the similar kind of queries which are already answered here in frequently asked questions, right? So this could be another task which can be done using machine learning. Okay, another task could be that from the specification, reviews and FAQs. Okay, can you answer any questions which is newly appearing on the page? Okay, so that is also possible, because ultimately the questions which are going to arise would be will be present from can be easily answered from the existing data what you have on the same page. Okay, so that could be one again problem or task which could be solved using machine learning. Another could be recommending the users with the same right and the most relevant products. Okay, so you can have some recommendation of the other products here, maybe with the different colors, or maybe with the slight change in the specification, or so on. Okay, so these are the different tasks what you can define if you have data with you. Okay, now coming to the model. Okay, so what is the mathematical formulation of the task? Okay, so that I can use this mathematical equation to do the same kind of operation on the new instances. Okay, so I need model for that. Okay, and the model is defining the relationship between input and output. Okay, so I will tell my machine that, see, there is some relationship between x and y. Okay, but from the family of function, the machine has to figure out what is the most the best fitted curve or the model I can have for the given data. Okay, so that is what the machine learning does. It tries to figure out the best function which describes the relationship between x and y from the family of functions. Okay, so like, see here one example. You have this kind of functions. The relationship between x and y looks quite nonlinear here. Okay, and I just try to fit. I say that, okay, there exists some relationship. Okay, some non-linear relationship between x and y, but machine has to figure out that whether the relationship is quadratic, whether it is cubic, or it is of any high order polynomial, right? So the algorithm will start figuring out with the polynomial of degree 1 by fitting the straight line, and will see that, no, this line is not describing the data correctly. There's a lot of error between the predicted value and the actual value. So maybe this line would not work. Then it tries the quadratic equation. Okay, tries out the cubic equation, and thus it keeps on trying the different equation and will figure out the equation for which the loss function is minimal. Okay, so for that we define this learning algorithm and the loss function, that it basically tries to find out the equation for which this loss function is minimal. Loss function is nothing but the difference between the predicted values and the actual values. Okay, and for whichever equation this loss function would be minimal, that would be taken as your model. Okay, and so now you know the values of the coefficients which is describing this equation, which is ABC here. Okay, so learning algorithm is giving you the optimal values of this A, B, and C, and now you're using this as the model, and you can just plug in the new values of X into this model and use this model for prediction. Okay, so this is what the idea is. Okay, and once you are done with your finding the right model for the data, the next thing would be evaluating your model. Okay, so you have different performance evaluation metrics corresponding to the different machine learning algorithms. Okay, like for the classification, I have taken here one example. Let's say you're talking about the autonomous vehicle, driverless car. Okay, and this car has to decide, that at what distance this car has to put brake if a dog is in front of, okay, or maybe an obstacle is there. Okay, so here, this is a classification problem, whether he has to put brake or no, okay, or go, and at what distance. Maybe that is another feature you can add to it. Okay, so you are evaluating the performance of this model, saying that, okay, how many times it is happening that a dog is present, okay, and you have put the brake correctly, or the car has put the brake correctly. How many times it has happened that when the dog was not there but still the brake has put, okay, or when the dog is there but the brake has not put. Okay, so these are the different scenario where you need to identify rightly the false positives and the false negatives. Okay, and the true positives and the true negatives, so that you can evaluate the performance of your model. Okay, and accordingly you can take the right measures and modify your model, right? So this is about the 6 building blocks what you have in machine learning algorithms. Okay, and definitely for all this you require the basic mathematics. Okay, so this is the prerequisite you have for machine learning and deep learning. You need to have a sound understanding on linear algebra concepts, probability concepts, and the differential calculus concepts. Okay, so this is the prerequisite. Okay, and now coming to the typical data science project life cycle. Okay, so we follow the particular framework which is well proven and robust. Okay, and that framework is referred as crisp DM framework. Okay, there are multiple frameworks, but this is what the framework is widely used. Okay, which stands for cross industry standard process for data mining. Okay, and it basically talks about the data science project to be executed in the series of steps. Okay, so you start with your business understanding, defining the objectives of your problem, defining the goals of the analysis. Okay, uh, talk about the data curation, data acquisition. Then you talk about the data understanding, data preparation. Okay, and then modeling, model evaluation, and finally model deployment. Okay, so these are the steps what we follow to have, to execute any data science project. Okay, so understanding on the business is very much required, that what exactly you're looking for. Okay, and based on that you will be going ahead. Okay, so you should be very clear with the objectives, otherwise you'll be super efficient in solving the wrong problem. Okay, so make sure that you are understanding your problem correctly, and based on that you are going further. Okay, now when we talk about, that, okay, you're clear with your business objectives or whatever problem you have in hand which you're trying to solve using data science or machine learning, after data curation, which is you have to make sure that you have taken the unbiased sample of the data which is correct, complete. Okay. And after that, you talk about the data understanding part. Okay, that how are you understanding your data in terms of maybe the univariate, bivariate, or multivariate analysis. Okay, you are trying to check, that what kind of features you have. Okay, what are the typical range of the features you have, what are the typical categories of the features you have. Okay, and you are just summarizing your data, checking out the distributions of data. Okay, checking if there are any missing values present in the data, if there are any outliers present in the data. Okay, whether your data is having any inconsistencies or quality issues. So you have to just make sure that you deal with all these inconsistencies and quality checks. Okay, and then you are preparing your data. Okay, so you make sure that you are selecting the right attributes or the features for your analysis. Okay, and that is the part of the data preparation, doing the feature engineering, standardizing the values so that they appear on the common scale. Okay, so that your interpretation or inferences don't go wrong when you're doing the analysis. Okay, your 60 to 70 percentage of time of this whole process will go in data curation, data understanding, data cleaning, and the data preparation. Okay, so that is the crucial part of your data science project life cycle, where your lot of time and energy will go in this part. Okay, but this is the most crucial and the required step which you have to do. Okay, and then comes, once your data is prepared, you have taken the right and the most relevant features in your analysis. Okay, then comes the modeling part. Okay, so then you talk about, choosing the right model as per your data, dimensionality of the data, the problem what you're trying to solve. So you decide the right model. Okay, and then you build that model. You basically train your model on using the training data, and then you evaluate your model on the test data. Okay, so you make sure that your model, whatever you are using, is succinct, it is mathematically sound, it is simple, easy to use. Okay, and it is robust. Okay, so that it is it is equally performing or even better performing on the test data or the unseen data. Okay, so that is what I meant by robustness of the model. Okay, so these are the typical algorithms you have in the regression and classification and in clustering. Okay, so we have the baseline model for regression as linear regression. We have support vector regressors. We have polynomial regression. We have stochastic gradient descent regressors. Okay, decision tree regressors, and so on. Okay, in classification, we start with the baseline model as logistic regression. We have naive bias, k nearest neighbors, decision trees, support vector machines, random forests, and different kinds of ensemble techniques and neural networks. Similarly, for regression, also we have neural networks. Okay. Then we talk about the unsupervised machine learning. In clustering, we have k-means, clustering algorithm, hierarchical, DB scan, hidden Markov models, neural networks. So these are the different clustering techniques we have, which we use for segmentation. For dimensionality reduction, we use principal component analysis, PCA, or maybe the latent factor analysis. Okay, so we actually do not talk about reinventing the wheel. Okay, we just use the existing models which are already developed as and available as API. Okay, and we go ahead and use those for to solve our problem in hand. Okay, so once your model is built and evaluated and everything looks good, you talk about the deployment of the model in production ready environment. Okay, so you are basically saving your model as a file. Okay, you can call it as a pickle file. Okay, and you are just saving that particular model as a file and just deploying on maybe on the web server or maybe at the IoT edge. Okay, so you can have the different kinds of deployment ways. Okay, it totally depends whether you are deploying the model on the batch process, or it is real time application or near real time application. Okay, so you have the different APIs available for the model deployment, known as Flask, or maybe you can use the container orchestration solutions like Kubernetes to deploy your model. Okay, and we basically prefer, the language here, a scripting language, as Python, because Python has all this deployment as well as the development APIs available, okay, for machine learning and the deep learning. So Python is quite easy to understand. It's quite easy to read and write. Okay, and you have the large open community to provide the help. Okay, and all the packages of machine learning and deep learning are being developed in Python. That is the reason why we prefer using Python as a scripting language for machine learning and deep learning, right? So now, once you understand this, we talk about what are the different roles and the responsibilities you have. Okay, and if I just want to fit this in a pyramid, okay, this is how it looks. Okay, you have the job roles belonging to data engineers. Okay, which basically these are responsible for data curation and defining the tasks. Okay, what exactly you are doing with that data. Okay, that is a task can be divided as maybe data engineers and data analyst. Okay, understanding your data, cleaning your data, preparing your data, and analyzing the data through maybe the statistical models or through the visualization is all done by data analysts. Okay, data scientists are responsible to do the required feature engineering. Okay, the model selection, building the model, and evaluating the model. Okay, so that is the part taken care by data scientists. ML engineers are responsible one step ahead. They understand the machine learning models, algorithms, and they basically take ahead this further and talk about the deployment. Okay, so that is taken care by ML engineers. Okay, and at the top of the pyramid, you have researchers. Okay, those who work in developing and designing the fast, efficient, and the better algorithms. Okay, which are being used by all of us. Okay, so now I just want to talk about that what kind of projects I have worked on. Okay, related to data analytics or machine learning. Okay, so I have worked as data analyst in an IoT based product company where we were working on the cold chain industry related problem. Okay, and here the main challenge was the improper maintenance of tight temperature range or the humidity in chillers. Okay, so this project was done for Big Bazaar, and here we were just trying to monitor the temperature or the humidity range the chillers are having, and so that we can save, we can avoid the damage of the perishable food items or the medicines. Okay, so this is what the problem we had. Okay, and this problem was basically based on this time series anomaly detection. Okay, so we were trying to figure out that that the whatever data we had for the different chillers. Okay, we were just trying to see this in real time if the temperature exceeds the given range. Okay, and if it exceeds, then those data points should be identified as anomalies. Okay, and this detection we had done in real time using the statistical models. Okay, like ARIMA. Okay, which is auto regression integrated moving average model. Okay, and this is a statistical model which we used. Okay, and here we were just taking the different parameters, hyperparameters, tune parameters like P, Q, and D. Okay, where we were just taking the lag values of the data points, voltage values of the data points at different legs. Okay, we were also taking the making sure that this particular model is applicable only on the stationary data. So we make sure that whatever data we have, we just take the difference, and applying the differencing operation and making sure that the data is converted into stationary data. Okay, and we were also taking the lagged forecast residual error values as a part of the moving average, and this altogether is referred as the ARIMA model, and we use this model to detect the anomalies, okay, using the rolling mean and the rolling standard deviation. Okay, but you have a variety of statistical model for anomaly detection. Okay, and if you talk about the neural networks, the LSTM, recurrent neural network, has its wide use cases in time series forecasting and anomaly detection. Okay, so it outperform the statistical model like ARIMA or SARIMA. Okay, but the difference between these two would be that the ARIMA is the statistical method, so it does not require the label data. Okay, however, here the models which are based on machine learning or deep learning, they require the label data to be present, and then only you can train the machine on that label data, and then you can go ahead with your test data, right? So, what I'm trying to tell you here is that with respect to this, that anomaly detection is, has its wide use cases. Like, it is applicable to detect the bank frauds or maybe the medical problems, okay, or structural defects, malfunctioning equipments. Okay, so this anomaly detection has its wide use cases in almost every domain. Okay, and you will have the multiple problems to be solved with respect to this topic. So this could be a good project or the research topic to be worked on. Okay. Another project which I had worked on is related to the recommendation system. Okay, like how the you would have seen the Amazon recommendation system or the Netflix recommendation system, how it works. Okay, so the moment you log into Netflix, it gives you the recommendation, right recommendation with respect to what movie you can watch or what web series you can watch. Okay, or maybe the popular genre based movie. Okay, or the similar users have also watched this. Okay, so this kind of recommendations are given to you on Amazon or Netflix. Okay, so how this recommendation system works. Okay, so it works on machine learning, where you are basically clustered or put into the different segments. Okay, based on your browsing history, your shopping history, your purchase history. Okay, or your shopping behavior. Okay, or what is your click rate, how much is your dwell time. Okay, so understanding all this, you are basically clustered or put into different segments. Okay, and then you identifying those segments, okay, and relating you with your most similar users. Okay, you are given with the recommendations. Okay, so this is what the idea as a whole. Okay, but if I just talk about the technical, what algorithms you have, machine learning algorithms you have in the recommendation engines, is these three types of algorithms. You have content based filtering, you have collaborative filtering, and you have association rules learning. Okay, so content based filtering, as the name suggests, here you basically find the products with the similar attributes. Okay, so let's say you have watched a particular genre movie, let's say a love story. Okay, and now next time when you log in, and if it is a content based filtering, then you will be recommended with the same genre movie, love story. Maybe the casting could be same. I'm talking with respect to the attributes. So one of the attribute could be cast, one of the attribute could be the director, one of the attribute could be the producer or the music director. Okay, and so on. So you have different attributes, and based on the attributes, okay, you are recommended with the similar kind of product. Okay, so this is the content based filtering. Okay, collaborative filtering means you are finding the products liked by the similar users. Okay, so whatever you are liking, maybe it is liked by me. So now whatever I am buying, that is recommended to you. Okay, because we belong to the same cluster, we are identified as similar users. Okay, so you are recommending, the products which is liked by the similar users. That is the collaborative filtering. Okay, and association rules learning is, you are finding the complementary products. Like, if you are buying mobile, then you are recommended with the headphones. Okay, so you are just trying to set the association between the different products, and then you are recommending, right? So these are the three algorithms mainly we have in the recommendation engines, and most of the time the collaborative filtering is used because it is based on the user ratings. Okay, so widely used technique is collaborative filtering because it helps creating the personalized experience for a user. Okay, and recommending the users with the right and the relevant products. Okay, and thus improving their shopping experience and ultimately the sale and the revenue, right? So here the algorithm what we use in the collaborative filtering is referred as KNN. It is a combination of classification and the clustering problem, and we use this K nearest neighbor algorithm here in order to identify the nearest or the similar users. Okay, and that is based on some distance metric. Okay, so here all the users are arranged as records or rows, and all the products are arranged as columns, okay, or attributes. And here all these data points or the users, you can just imagine that they all are the vectors in a n-dimensional vector space. Okay, and then you are just trying to find out, defining some distance measure or the similarity measure, which could be Euclidean distance or cosine similarity or Hamming distance or Manhattan distance. So you have variety of distance measures using which you can just calculate, that whichever user is more closer or in the nearest proximity would be considered as more similar users. Okay, and such way you will be finding the k nearest neighbors. Okay, let's say here k is equal to 3, so you are finding the 3 nearest neighbors. Okay, and whatever you are just taking the weighted average of the ratings given by the similar users, and then you are just sorting those ratings into descending order and giving maybe the top 5 or the top 10 recommendations to uh, new users. Okay, so this is how the recommendation system works. Okay, and you can recommend the users on the basis of different uh, attributes or functionality. Maybe you can recommend the users with the products which are clicked multiple times. Okay, that could be one criteria. Another could be the criteria on the purchase likelihood. Okay, third criteria could be that just suggest something which is newly appeared, or maybe you feel that the customer may like, so that is a surprise item. Or maybe you can recommend the items which are highly rated by the other customers. Okay, so you have different the ways in which you can recommend the different products to the user. And in practice, in real time, you do not have just one machine learning model which you deploy. It is always the series of models, okay, or the combination of models what you deploy uh, in the production ready environment. Okay, so like here one example I have taken. Okay, you're talking about the language translator. Okay, application by Google. So you have the series of models here. Okay, which generally you write as a pipeline. Okay, and then deploy as a pipeline. So one model could be to detect the image. Okay, one model could be using the optical character recognition to identify the characters and the language. Okay, another model could be the language translator. Okay, whichever language you are looking for that to be translated. Okay, Another model could be, to place or superimpose that particular word onto the existing image. Okay. And another model could be adjusting or readjusting the font size. Okay. So you can see that, always in practice or real time, you have the series of ML models taken as a pipeline, and it has to be executed in pipeline, and functioning accordingly. Okay. Like here you see the Google Translate. So you have multiple models here, which is specific to a specific task. Okay. So just to mention here, that whatever AI we are discussing here is referred as a narrow AI or weak AI, because here the machine learning models, you have one machine learning model for a specific task. Okay, so when we talk about the future AI is going to be AGI, which is artificial general intelligence, and there, we say that, okay, one particular model would be able to do all the tasks, okay, like human, how we take decision the same way. Okay, so AGI doesn't exist yet, okay, but it is, the work is going on towards AGI. Okay. So this is about the different use cases, the process flow, the algorithms, what we have in machine learning and AI. Okay. And if I just talk about the opportunities, what you have in AI ML. Okay. So you can see that, these industries. Okay, when I talk about the video conferencing applications, fitness applications, e-learning platforms, OTT platforms, social media. Okay, considering the new normal, you can see here that the customer base for all this industries have risen up. Okay, and you can see the percentage of increase in the time spent on this platform. Okay, so all this applications or platforms are AI ML driven. Okay, and thus the demand for the skilled professionals is going to be very high. Okay, in all these domains. Okay, similarly you have a lot of scope in biomedical research. Okay, in diagnosis and preventive healthcare clinical research. You have a lot of scope where AI ML could be applied, specifically the deep learning neural networks. Okay, for the image classification stuff. Okay. Similarly, you have a lot of scope to work with the conversational AI. Okay, and the cyber security in financial domain. Okay, so these are the fields which are booming up post COVID. Okay, and now what are the skills required to go ahead with this? Okay, so as I had already mentioned, that it is a multidisciplinary field, and you are required to have the good hold on the mathematics and the statistical concepts. Okay, to do the required mathematical and statistical analysis in order to understand the algorithms and the functionality. Okay, you should have a good command on the programming language like Python or R. Python is preferred. Okay, and along with the domain expertise. Okay, so these are the skills what you are required to have, and these are the tools on which you will be required to work. Okay, so you have the Python, R. You have the different machine learning tools, packages like scikit-learn, TensorFlow. You have data visualization tools like Tableau, Power BI, Excel, MATLAB. Okay, big data, Apache Spark. Okay, so these are the different tools. Okay, depending on what you're choosing, you can start working. Okay. Now, talking about the research scope in AI. Okay, so research scope, the very first thing when you talk about the research, and you are trying to do the research in AI ML domain, the very first thing that what kind of data you have, whether you have data for the given problem. Okay, that is the very important and the crucial part, that whether you have the data with you. okay, or how, if you are, looking at the all possible scenario or the real time scenario, are you able to generate the right data, okay, on which you will be training your model and further going ahead with. Okay, so always remember, the quality of your output would be determined by the quality of your input. Okay, the better quality of the data you provide as an input to any machine learning algorithm, you will expect the desired result out of it. Okay, otherwise it is as simple as garbage in and garbage out. Okay, so make sure that whatever problem you have in hand, you have the relevant data, right, and the relevant data with you to go ahead with. Okay, now it particularly, with respect to the telecom domain, if I talk about the scope, um, the majority of work could be done in the predictive maintenance. Okay, this has got the wide use case in terms of, say, not only just saving the time but also saving a lot of money. Okay, so preventive maintenance is applicable to any domain you name. It could be related to the mechanical equipments, okay, like your wind turbines or engines, okay, or any equipment. Similarly, in the telecom domain, whenever you are talking about, you are trying to identify and detect that a particular equipment, okay, should not slow down or shut down. Okay, and that downtime basically you are trying to prevent. And before going into that mode, prior to that, you want to take the right action or measure in terms of either replacing the equipment or doing the right maintenance. Okay, so predictive maintenance has got its wide use cases in almost every domain you name. Okay, so this could be a very good topic to be worked on. And we can predict the failure status of the different equipments using the classification algorithms, and we can predict the remaining useful life by using the regression techniques. Okay, so you can use all this machine learning models in order to do the predictive maintenance. Okay, and you also have a lot of scope in cybersecurity, in what do you call, the resource management, the mobility management, and with respect to 5G cellular networks. Okay, so we all are already aware the technologies what we have in 5G cellular networks. Okay, that it is using the millimeter wave spectrum, which is ranging from 3 gigahertz to 300 gigahertz. Okay, and this is the band which is quite unused. Okay, and we know that the 1 to 6 gigahertz band is already overcrowded, and thus the millimeter wave band is getting explored, okay, for the 5G application. Then we talk about the massive MIMO, where we have this multiple input, multiple output antenna arrays, which could be used by 5G cellular networks. Okay, and then it is a small cell because we have high frequency and the range is limited. The antenna size is quite small, so we are talking about this small cell technology here. Okay, using the beam forming concepts. Okay, where it is just leading to the laser like beams for the different individual users, trying to reduce the interference. Okay, and thus what do you call, the less energy consumption and high data rates for the different users. Okay, so we already know about these technologies. Okay, that it is using the non-orthogonal multiple axis techniques. Okay, to provide the high sum rate. Okay, and the last one is the mobile edge computing, in order to take care of the latency requirement what we have for the applications like augmented reality or the video conferencing, right? So at the edge of the mobile, we can have the duplication of this cloud, and we can reduce the latency and the data rate requirement here using this mobile edge computing technology, right? So these are the six main technology what we have in with respect to 5G cellular networks. Okay, and all this technology have a lot of scope, to work on with respect to machine learning and artificial intelligence. Okay, it has a lot of potential and possibility in resource management, in mobility management, in localization problems, in efficient spectrum utilization, maybe in the wireless compressing techniques for spatial anomaly detections in wireless sensor networks, network security. So you have a lot of scope in 5G cellular network where you can work using this reinforcement learning or Q learning techniques. Okay. So here I have just included this one more slide where I would just like you to have the use the effective sources for the learning and the skill development. Okay, you can just refer all your project or research related work done by others, and you can be the part of your active community on GitHub. You can update your profile and be active on the LinkedIn. Okay, join the active relevant groups to keep yourself updated with the kind of work you are doing. Okay, and subscribe to this Medium or some other journals for the relevant informative articles. This is going to help. Okay, so all these platforms you should be very active on, and you will have a lot of learning. So this is it from my side, and I hope you found the session informative. So if you have any queries, we can have that query session now.
Hello, ma'am. Yeah, it's a wonderful session, ma'am. So, and the participants has given the very good feedback. So, like, good session. And there are some few questions are there, ma'am. Yeah, ma'am. The first question is, ma'am, why AI topic in 5G program?
Sorry, I couldn't hear you, sir. Can you repeat?
Yeah, ma'am. Why artificial intelligence topic in 5G program? Whether it's a part of 5G.
Yeah, it is an integral part of 5G. Like that is what I actually mentioned here in my presentation. That when we talk about the 5G different technology, like you talk about the MAC layer, the resource allocation or mobility management. Okay, you have a lot of scope to apply this reinforcement learning, and deciding on that if you know the, let's say if you know the user's preferences. Okay, can you predict that what the user's next location is going to be, what is the mobility parameters the users are going to, so that you can accordingly take a call and allocate the right resources to the user based on the application the user. Okay, so for the handoff application, for the mobility application, or maybe for the resource allocation, this machine learning or reinforcement learning could be used in order to predict the behavior of the customer or the requirement of the customers.
Okay, ma'am.
Okay.
Okay, ma'am. Yes, ma'am. Thank you, ma'am. So all of them have given the good feedback, ma'am, regarding your
Okay.
session, like excellent session, good session, nice presentation. So yes, ma'am.
Okay. Okay. Thank you very much. To be part of
So
this event.
yes, ma'am. Thank you very much for sharing your knowledge regarding this one in our STP, ma'am. So now would conclude. We'd like to conclude day 3 of this AICT sponsorship time training program. So
Mhm.
thank you, everyone. So thanks for attending, ma'am.
Thank you
Thank
so
you.
much. Yeah. Have a nice day. Bye bye.
Bye, ma'am.